In this problem, our goal is to solve for x. I can tell that this problem is a trigonometry problem because the diagram includes measurements for both sides and angles. For example, the 11 inches is a side of the triangle, and the x is also a side of the triangle, where in contrast, the 59 degrees is an angle of the triangle. Whenever you have a diagram of a triangle where there are both sides and angles involved, that's your indication that you need to use trigonometry. Like all other trigonometry problems, the first step is to label the triangle so that way we can identify which trigonometry formula to use. And so that's what we're going to do. First, start by making sure that the triangle is a right triangle because sine, cosine, and tangent only work for right triangles. And then next, you need to identify the theta. Theta is a Greek letter, and theta will be one of the two acute angles in the triangle, and you can tell which one to pick based on where the measurement is. So the 59 degrees tells me that this corner is the one that should be theta. Next, we need to label the three sides. Start with the longest side, which is called the hypotenuse. The longest side of the triangle will always be across the triangle from the right angle in case it's too difficult to tell. After we have the hypotenuse, the next side to label is the opposite side. The opposite side of the triangle can be found by going across the triangle from theta. And so that's why we needed to label theta first. So this side right here, this blank one, is the opposite side. And then the final side to label is called the adjacent. Save the adjacent for last. It'll be whichever side's left over. And the word adjacent means next to. And the reason why it's called that is because the adjacent side will always be next to theta. So notice how the blue side is next to the theta. After labeling, we now can look at the three options. We have three choices for trigonometry. We have sine, cosine, and tangent. And we can use these labels to figure out which of the three formulas is the best one to choose. When we look at the three labels, notice that only two of them are relevant. We have the 11 inches on the hypotenuse, that's important, and then we also have the variable x, which is on the adjacent side. The third side, the opposite, this one is blank and has no measurements, and so that one will not be used in this problem. So now we look at our three options, and we're going to need to find which formula uses A for adjacent and H for hypotenuse. The way I have this written down is in the format of a memory trick. The memory trick is called sohcahtoa, and you may have heard that before. Sohcahtoa is how you can remember all three formulas without actually having to memorize the formulas themselves. So so, ka, and toa is the memory trick that's happening here. So we're just matching the letters. We need to find A and H. So I look through each of the three options. I notice that, nope, that one doesn't have an A or an H. I look at the second one, and yes, this is the option that we want to choose. The A and the H for adjacent and hypotenuse, and the letter C stands for cosine. So in this problem, we're going to use cosine to get our answer for solving for x. So let's write down the cosine formula. In this problem, I know to use the normal cosine formula because we are solving for a side of the triangle. If this had been a problem where we're solving for one of the corners, then we would use inverse cosine. After the parentheses comes the equal sign, and then after the equal sign is the fraction, which is based on sohcahtoa. We need to put the adjacent on top, and then on the denominator of the fraction is the hypotenuse. Let's fill in this formula with the three measurements. We have the measurement for theta, which is what we'll start with. The measurement for theta is 59 degrees, so we'll put the 59 in the parentheses. On top of the fraction, we need the number for adjacent, which in this case is the variable x. And then in the denominator, we have the hypotenuse. That measurement is the 11 inches. So now we have the formula filled in. Our job is to solve this for x, which means to get x by itself. The best way to get x by itself in this particular problem is to cross multiply. And we can use cross multiplication by turning the left side of the equation into a fraction. Right? We can place this over 1, and now we can cross multiply. On the first diagonal, so let's do 1 times x. and then that is equal to the other diagonal. So that would be the 11 times cosine. So we have 11 times cosine, and the 59 is connected to the cosine, so we'll bring that down as well. Now this successfully has gotten x by itself, and that's because 1 times x is simply x, which means we've successfully solved for x. The last thing we need to do is type in the right-hand side of the equation to figure out what number that is for our answer. So I'm going to pull up a calculator on our screen. On your calculator, make sure that your calculator is in degree mode. To check on a TI 83 or 84 calculator, you can click the mode button, and a little bit down on the menu there's the word degree. Make sure that that's highlighted. To get out of the mode menu, click clear, and it'll bring you back to the home screen. So we need to type in 11 and then multiply by cosine of 59. So cosine, I'm going to put the multiplication in there, times cosine of 59. When we hit enter, it will give us the result. Let's round to the hundredth place. So in this case, we have a result of 5.67. So we'll write down our answer of 5.67. And we are solving for the side of the triangle, which the sides are in inches. So I'll put my units of inches, and that is our answer. Now, I do want to point out real quickly that there is a way to skip the cross multiplication step to predict how to type it in the calculator. Some of you may know this already, but the top of the fraction, when the top of the fraction is the variable, that is when you'll multiply in the calculator. And if the variable was on the bottom of the fraction, then you'll end up dividing in the calculator. Okay, those patterns are true for all sine, cosine, and tangent trigonometry problems. So that's all for today. Like and subscribe.